And here's a photo of a chunk of this material from the South Tower, about a 40-pound chunk. It's about 9 inches square and about 3 or 4 inches deep. And we have now a small sample brought to BYU for analysis. Now the latest results, which I would call compelling. But remember, these aren't yet published in a peer-reviewed journal, so I have to be a bit cautious as a scientist. And here we're back to this material, previously molten metal. Here's the data, which very few have seen now outside of BYU. And this is what that Professor Campbell was reacting to. On the left, we see abundant iron. Now the white means there's a lot of this metal, and the dark regions are where there is less of it. This is what you expect from a melt with other stuff in there. You expect regions of high concentration, which is the white bands, and then low concentration, which is the dark. And then on the right you see aluminum, but it's definitely there, but in spots. It's not mostly aluminum, it's mostly iron. We can strictly rule out molten aluminum from the plains in this material. It's a big chunk, remember, from the South Tower. Secondly, we see, and there's iron again, upper left. On the right is chromium. And what that is just noise. There's no pattern. This is just background noise. In other words, there's very little chromium. Now, steel has a fair amount of chromium in it. We're confident that we can rule out molten structural steel, but we don't make that statement conclusively yet until we do some more checking. On the other hand, there's a great deal of manganese, but notice it anti-correlates. The white regions, more iron, but then there's less manganese. And when there's less iron, dark regions, there's more manganese. That's an anti-correlation, which suggests that the manganese is not from steel. It's from something else. Now, potassium permanganate, which has manganese in it, is commonly used in thermites, aluminothermics. Here we see aluminum, upper left, potassium, again, potassium permanganate, you'd expect potassium, and sulfur in spots. So we see all of those. Most of the sulfur you would expect to be burned off, by the way, but there's still some there. And as Jim Fetzer mentioned, is in my paper too. Another group, and this is in FEMA Appendix C. You won't find it in the NIST report, which comes later, but for some reason they just don't mention it. This is that sulfidation, in other words, sulfur attacking steel at high temperatures, was found by Professor Barnett and Sisson. There's a little group there, Massachusetts. Good work. Evidence of severe high temperature corrosion, attack on the steel, including oxidation, we do see oxygen, and sulfidation, we do see sulfur, with subsequent intergranular melting. This is sulfur makes it melt at lower temperatures. Boom, it slices right through. Was readily visible, they report. And this is completely consistent with our observation and becomes a second corroboration, which in science now becomes compelling, if not conclusive. We're somewhere between compelling and conclusive right now. Now, I'll share with you there's some other elements which I'm not going to share because I just want to check them out first. But manganese in abundance, and lower right, you see the fluorine. Now, where in the heck does fluorine come from? That's unusual to have fluorine. Chlorine, yes, but fluorine, where does that come from? Well, in thermites, fluorine is present in an oxidizer, which we can all read this, a polytetrafluoroethylene. Okay, the fluoro in there is fluorine. And the potassium, manganese, and fluorine are often present then in the residue. Have you checked other samples? Yes. This sample clinging to this structure. This is a way to cut through steel of substantial thickness. An invention goes back to 99 using thermite. This quoting, invention uses thermite. Cut through thick stuff, substantial. These are super thermite. Remember what that is? Real fine thermite, so it's explosive. And this, you put electric current through this match. It's called an electric match. You put an electric current through the wire. The super thermite's out here, and that will touch off then the thermite or super thermite. If you want an explosion, use super thermite. If you want it to cut without an explosion, like in the South Tower, you use regular thermite. It's clear. Oh boy, there's so much we can talk about. I'm going to have to skip some of this though. Research by, look, I think this is neat though. Chicago meeting, Kevin, he said I could talk about this briefly. Sol gels, these gels that are used to hold the aluminum particles and the iron oxide. And these materials now can be cast. And so you can cast this stuff. Now it's explosive. You put it right on the steel, man. Touch that off. You know, radio control to a super thermite match. Touch that off, man. I mean, we're figuring this out, how this could be done easily. And then we're seeing traces of this. But wait, with this stuff, this sol gel leaves this trace. This residue is not always there, but it would certainly be consistent with the use of these sol gels. And so guess what? Little drum roll. This is an important one. Okay, here it comes. One molecule, is quoting now from a newspaper article, EPA's Eric Schwartz. One molecule described by EPA's Eric Schwartz was present at levels, quote, that dwarfed all others. 1,3-diphenyl propane. You're going to hear more about this. We've never observed it in any sampling we've ever done, Schwartz said. Now, they've looked at a few burning buildings before. All right? They never saw 1,3-DPP before. Here it is, and it's characteristic of these sol gels used with thermite. Folks, we are nailing this, I think. You know that. Now I have to throw in, since that's Kevin Ryan's work, he says, I'm still working on it. I really want to nail it. But can you prove arson with thermite? I'm quoting now from Materials Engineering, MEI, what is it? It's some group that does this study of thermite arson. This gives me hope. They say, in recent years, the use of thermite reactions as incendiary, what's that? Fires, burns slowly and so on. Okay, as incendiary devices has gained popularity with arsonists because they are easily ignited, like with the super thermite match. They burn quickly, in fact as quick as you want, really, can generate a very intense heat in excess of 4,000 Fahrenheit. By the way, this was published before 9/11. These substances are a mixture of copper oxide, of course you can use, I mentioned, iron oxide, molybdenum oxide, etc., potassium permanganate, other chemicals which can be homemade or purchased commercially, no tagans. Quoting out of the same article, when thermite reaction compounds are used to ignite a fire, they produce a characteristic burn pattern, which is white hot reaction region, white plume of aluminum oxide coming off, and then, the ash, and then the yellow molten metal, right, which later solidifies. They leave behind evidence. Boy, do they ever. These compounds are rather unique in their chemical composition. They contain common elements, depending on what you use, copper, iron, calcium, silicon, of course some aluminum always, but also more unusual elements such as vanadium, titanium, tin, fluorine, and manganese. And we see some other unusual ones which, for reasons you can imagine, I'm not going to go into here in detail. But as we nail these, then I'll have them. We'll publish them. While some of these elements are consumed in the fire, many are also left behind in the residue, and that's what we're looking for. Now this is hope. MEI has conducted energy dispersive spectroscopy. Minute traces is all you need. That little chunk I held up earlier today, I got it here, but it's just a little piece of this molten stuff. Identifying the presence of these chemical elements. We use that technique too. The results, coupled with visual evidence, which we reviewed just a minute ago, flowing metal, white ash, etc., provide absolute certainty that thermite reaction compounds were present, indicating the fire was deliberately set and not of natural causes. In other words, so what's happening is turned into an arson investigation, is really what it is.